Hi everyone, Susie here with part 2 of the Java Basics video series. Last video we set up our IDE using IntelliJ and downloaded and installed JDK. Then we went over the basic structures of a Java function. Today we will go over data and expressions. So open up your IntelliJ or your choice of IDE, grab a pen and notebook, and let's get started. To start, I've created the simple countdown program. As a review, the class starts with public and class, and then the class name, usually the title of the program, and then open and close curly brackets. Inside these brackets, we have a method. This method is the main method indicated by public static void main string args, and then another set of curly brackets. Finally, inside these curly brackets, we have our set of instructions or statements. Now, each line or statement starts off with a command, followed by a string, followed by a semicolon. The command tells Java what you want to do with the string, which is in a set of parentheses and double quotation marks, and the semicolon ends the statement. The parentheses indicate a specific instruction for the command and indicate that the text in between the quote is a string of characters. As you can see here, when we run the program, we see each line individually printed out. This is because we are using the print line command. There are two types of print commands. The first is the print line, as you see here. Tells Java that we want whatever is in the string to print, then go to the next line and print the next set of instructions. So you can think of print line as just that. Just print the line of code and then go to the next line. So we have 5, then the next line 4, then the next line 3, and so on. Now here is the same program, but now we are using the other command, print. The print command tells Java to print the line of code and go to the next instruction and print that line of code on the same line. The print command will continue to print each line of code on the same line until the end of the instructions or until some other instruction such as print line is used. In this code, we can see that we have the first 5 lines with the print command telling Java to print the 5 lines of code on the same line. We then end the line with the print line command, which tells Java to go to the next instruction and print those instructions on a new line. Notice I used print line on the last line. This is optional. You can use print or print line. The choice is yours. Now let's talk about string concatenation. What is concatenation? It is the joining of 2 elements. They can be strings and strings, numbers and strings, or numbers and numbers. Note that a number can be inside a string, but a number alone does not need quotations in Java. When concatenating numbers, it is not addition. It is the joining of 2 numbers. If you want to add numbers, then you need to add parentheses around the equation, which we will get to later on. And then Java will know that that is a specific equation. Now, a word of caution. Java doesn't know space. It knows it as a character, so if you add a space between your quotes, Java will read it as a space. However, the space outside of the string or quotes will not be read as a character. Therefore, in concatenation, when joining 2 strings or a string and a number, you need to make sure that you add the space in the string or Java will mush everything together, as you see here in the example of the 2 numbers. 452 plus 123 gets mushed into 452123. So here we have a program called facts, where we have several types of concatenation. The first set of examples is the proper usage of the space as a character, while the second example does not have the proper use of space as a character, which shows us how Java will mash the sentences together. So let's look at the first set of examples. In line 1, we have one solid string, no concatenation. Remember that in a string, we can add all types of characters and they will be printed out. So we use letters, numbers, and punctuation. In the second line, we have 4 separate strings and we use a plus sign to join them together. However, because Java doesn't recognize the spaces after the ending quotation marks, we need to add a space in the string. So at the end of each line before closing off the quote, except for the last string, we add a space. Now you could add a space at the front of the string instead. It doesn't matter. Practice this a bit and see how spaces work in Java. The next line is a joining of a string and a number. Since the number is alone, we do not need quotation marks around it. Java will read it as a number. Now, I made a small typographical error. Can you spot it? If you said I'm missing a period, you are correct. If I wanted to add a period after the number, I would have to add another plus sign and a period in double quotes. The next line shows us that we can add multiple types of concatenation, and the final line is the same. Now we can see what happens when we don't use proper use of the space. The strings are mashed together. So in the first line, use and smartphones becomes 1. Smartphones and tablets become 1, and tablets and become 1. In the second line, is mashed together with 480. In the third line, we see of and 130 and kph all mashed together. And then or, 80, and mph mashed together. Now for this sentence, you may want kph or mph next to the number without a space. That choice is yours. In the final line, we have is mashed into 4,490 mashed into people. So remember, when using concatenation, you need to use your space accordingly. Now let's talk about math. In concatenation, a number inside a string will be printed and a number alone will be printed. If you want to tell Java to perform math, you need to surround your numbers with the correct math symbol in parentheses. Java will read this as a math problem. Also, when adding numbers, they are their own entity, so you will not be able to just add 2 numbers inside a string. The equation must be concatenated to the string. So, where we have 24 and 45 concatenated, which meshes to 2 numbers together, you get 2445. The second line in the equation, you have a string followed by an equation. Thus, Java reads this and performs the operation. So we get 24 and 45 added together is 69. Too often, we add special characters to our strings. Java gets confused and doesn't understand how to read them. That is because some characters have double meanings, such as a quotation mark in the middle of a string. Java will take the second quotation mark and see that as the end of the string. So to avoid this, we add escape sequences, which starts with a backslash and then the character we wish to use. Here is a list of the different sequences you can use in Java. So in the case of the quotation marks, if we wanted to add quotes to our string, we would simply add a backslash before the quotation mark. Here is a program called escape, and here you can see how we use the different escape sequences. Now, not all escape sequences may work in your program. Try using some of these sequences to see how they work in your program. Let's look at the first example. We use the tab sequence to indent the line and end the line with the \n sequence to tell Java to go to the new line within the concatenation. Then we indent the next line. Because we use the command print line, Java will know that the next set of instructions will be printed on the following line. In the next example, we use the new line sequence at the end of red and blue. Then we add in quotations for the next line, skip to a new line, and end with quotations. Lastly, we use single quotes, added a backslash, skipped to a new line, and ended with a single quote. Okay, you're doing great. Now we'll talk about variables and assignments. What is a variable? A variable is a name for a location in memory used to hold a data value. This can be anything. The variable is preceded by a variable type. The type can be an integer, a floating point number, a string, or a character. So we can have a variable called count that will take a number or integer. So we say that the type is integer, referring to the number to follow the variable. Then we declare the variable count followed by the equal sign because we want a value to be associated with that variable and then the value. Again, we use the semicolon to close the statement. Let's break this down a little. Here are two statements. We have the variable type followed by the variable, then the value. As you can see in the second line, we can add multiple variables. In the first statement, we are declaring that there is a variable called count, and it will hold an integer. That integer will be the value 10. So in the program, whenever we want to represent 10, we just type in the variable count. In essence, the variable becomes a replacement for the value. Now, the value doesn't always have to be a number. It can be anything. Here is another statement where we have the variable keys that will hold an integer with a value of 88. Then we will ask Java to print a piano has, and instead of writing 88, we say keys. And Java will know to replace the word keys with the value of 88. So the output will be a piano has 88 keys. Here is a program called geometry. Can you guess what the program will print out? If you stated that the program will replace the word sides with the number we assigned to the variable, you are correct. Now, in this program, we have to restate what the variable will represent. We do not need to restate that it'll be an integer because the type remains the same throughout the program. We just need to say that for the next line, tell Java to replace sides with the value I give it. Thus, we will get the following output. Practice this and see what other ways you can use variables. Awesome, you are doing great. Now, let's talk about primitive data. There are 4 integer data types and 2 floating point data types. These data types range from smallest to largest. These data types were most important when computers first arrived, as data space was limited and thus it was crucial to indicate how much space you needed for programming. In Java, we use byte, short, integer, and long for the integer or numerical value data types. The byte is the smallest and ranges from a -128 to 127. This is 255 characters. This value is rarely used in today's computing, but you might see it still in databases. Short is the next value, holding 65,535 characters. Integer holds 4,294,967,295 characters. And finally, long, which holds way more than you'll likely ever use unless you may be in NASA. But you will use long if the value is greater than the capacity of an integer. Next are the two floating point data types, float and double. We haven't discussed really what a float is, so a float is a numerical value that is preceded by a decimal, such as 9.5 or 12.34. A float will hold 7 significant places, which are the values on the right side of the decimal, while a double will hold 15 significant places. So a number such as 76.12345678 would be a double, since the 8 is one more than the 7th significant figure in the number. You can use double for all significant figures 1 through 15. So we talked about integer data types. Let's talk about character and Boolean literals. Characters are all the letters of the alphabet, lower and uppercase, and all of the different symbols. In Java, the character literal is expressed in single quotes, as you can see here. String literals use double quotes, as we have been using in the past string examples. So if you want to represent a character as a value, you simply put the character in single quotes. So here we have char, or character, which is the data type for the variable top grade. Then we have the value, and instead of the numerical value, we have a character value, A. So when we write top grade, Java will replace the variable top grade with the letter and only the letter A. A Boolean indicates whether or not a condition is true or false, and only true or false. So here we have the value type Boolean, followed by the variable named flag, and when Java reads flag based on the conditions of the program, it will print out true or false. Let me break this down a little more for you. We have here two flags. One is red and the other is white. We set the variable flag to true. Then we have a condition such as if the flag is red, then the condition is true, else it is false. Therefore, when the flag is red, Java will replace the variable flag with true. If the flag is not red, then Java will replace the variable with false. Expressions are a combination of one or more operators and operands that usually perform calculations. Here you can see the different operators: plus for addition, dash for subtraction, star for multiplication, / for division, and a % for remainder. Java performs these operations left to right in the order of PEMDAS. If you don't remember PEMDAS, PEMDAS is a mnemonic for parentheses, exponents, multiplication, division, addition, and subtraction. So Java will look for operations within parentheses first, then perform exponential operations, and so on. An operation is the performance of an action. An operand is the value that will be used in the operation, and the operator is a symbol that will be performed. So here we have 14, which is an operand, and the plus sign, which is the operator. And it tells Java to add the first operand 14 to the second operand together. So the whole action is called an operation. Here I have a program called math. The first equation, we gave the variable result a type of integer. Then we set a value for it in the form of an operation. Java will perform the operation, and the answer is 21. Let's go ahead and break this down. Java will perform the order of operations from left to right according to PEMDAS. So our first operation here will be 18 minus 4, because we always work with the inner parentheses and work our way out. Once this is performed, we perform the next operation, 14 divided by 2. Once Java has solved that, it looks for the next operator, which is the exponent. Well, we don't have any exponents, so it goes to the next one, which is multiplication. Java will go ahead and multiply 7 and 3 together, and we'll get 21. Remember how I told you that the value will replace the variable? Well, here, Java performed an operation, we got an answer, and replaced the variable with the result of the answer. The final line says print the variable result, and it printed 21. The modulus operator is one likely you won't use too often, but we'll talk about it now. In the second problem, we have the variable remainder, which we typed as an integer. So the value of this variable will be an integer. Then we gave the variable a value of 17% 4, which is asking Java that you want whatever the value is left over after the operation of 17 divided by 4. So let's go ahead and take a look at that. Here I am asking Java to give us the remainder of the division problem of 17 divided by 4. When we set up the division problem old school, we place the second operand on the outside of the division bar and the 17 on the inside of the division bar. To perform the problem, we ask how many times does 4 go into the first digit, which is 1. It doesn't, so then we move to the next number and then combine the 1 with it to be 17. Then we ask how many times does 4 go into 17? 4 times. We know it's 4 because it's the highest value without going over 17. If we did 5 times, then 4 times 5 is 20. And 20 is larger than 17. So 4 times 4 is 16. We write 4 on the top of the division bar over the 7, and then we write 16 under the 17. We then subtract the two values. 17 minus 16 is 1. Because there are no other numbers for Java to perform an operation, then the 1 becomes the remainder. We write the R next to the 4 at the top of the division bar, and the 1 next to it. So Java will replace this answer with the remainder of the variable remainder. Here is a program called temperature. It will calculate the temperature in Celsius and in Fahrenheit. In this problem, I've used a variable called a constant. A constant is a variable that is in all caps, and it tells Java that the value for this variable will never change in the program. In this program, we have a variable base with a value set of 32. Then we have a conversion factor set to the equation of 9.0, which is a double, divided by 5.0, which is also a double. We then tell Java that we want a variable called Fahrenheit temp to be a double. We set Celsius temp to an integer value of 24 because it does not have a decimal place. Next, we give Fahrenheit temp an equation. Celsius temp, which is 24, multiplied by the conversion factor, which is 9.0 divided by 5.0, and then add the base of 32. Now we ask Java to print out the Celsius temp, which is 24 since it didn't have a problem to do. And on the next line, we print out the Fahrenheit temp, which performs the equation that we set for it, and that's 75.2. Hang in there, we're almost done, and you're doing great. Now, we will talk about incrementing and decrementing in Java. Incrementing is adding value, and decrementing is subtracting value. Incrementing is written with two plus signs next to a variable, while decrementing is written with two minus signs next to the variable. The plus or minus signs can be either at the end or the beginning of the variable. You can also write incremental values as the variable plus how many times you want to increment it by. You can do the same for decrementing. So, in the first example, we have the variable count, and we set it equal to the value of count plus 1. So, if the value of count is 15, then Java will increment the value by 1 and print the result by replacing the variable total with the new value, which is 16. In the second example, we are doing the opposite. We have a variable count and we set it equal to the value of count minus 1. So if the value of the count is 15, then Java will decrement the value by 1 and print the result by replacing the variable total with the new value, which is 14. Here is a program called Increment. Similar to what we just discussed, we have a variable called count, and we gave it an integer value of 1. Now this problem does incrementing and decrementing twice. So the first time we say count is count plus 1. The value of count is 1, so 1 plus 1 is 2. The next statement tells Java to increment the new value by 1. So the new value 2 plus 1 is 3. Then we print out the variable, which will be replaced by the new value of 3. For decrementing, we give the variable count 2 the integer value of 10. Then we say Java, we want the variable count to be the value of the count, which is 10, and decremented by 1. So 10 minus 1 is 9. Now take that new value and decrement it again. So 9 minus 1 is 8. Now print out count 2, replacing the variable with the new value, which is 8. Hey, you did it! Thanks for sticking with me to the end. Go ahead and practice the programs in the video and see what other programs you can create using your new skills. Next video, we will discuss using classes and objects. If you like this video, please hit the thumbs up and consider subscribing to my channel. Hit the bell icon so you never miss another video. Until next time, thanks for watching.